Okay, so I'll have to take another 10-minute break then. I'll get you set up with a problem before I do that though. Okay, so here's the question. L is equal to negative d squared plus 2d minus 1. And is x e to the x in the kernel of L? Does anybody know how to approach that?
Just put that into the formula and try to get 0.
Right, plug this into the formula for L. L is going to operate on this input. And the question is, does it give us 0? So let's do that. So for the solution, so this one's pretty quick. We just take negative d squared plus 2d minus 1, and we apply it to x e to the x. Okay? That's what we're going to do. What I would recommend before we get any further here is that we actually calculate the derivatives that we need kind of on the side so we can just plug them in. Right? So what is the derivative of x e to the x?
X to the x plus e to the x.
Let's see. I have to use the product rule.
Yeah.
So the first term, which is x, times the derivative of the second, which is e to the x, plus the second, which is e to the x, times the derivative of x, which is 1. So I think that's what you said. Perfect. Okay, and then let me take a second derivative. So now I'm actually differentiating this, which the first part actually gives me this whole thing, and then I have another e to the x on the end of it, so what's it going to be when you simplify it? 2e to the x there, and I'll have x e to the x in front of that. Okay, that looks pretty good. So what we're going to do over here, and by the way, again, these parentheses are very helpful. Right? So parentheses around L, parentheses around what you're plugging in, is we are going to take negative of two derivatives. So that's negative of x e to the x plus 2 e to the x. And then plus 2 times one derivative, x e to the x plus e to the x. And then minus x e to the x. And my question for you is, does that give you 0? So I have 2x e to the x, but I'm subtracting 1 here and subtracting 1 here, so that cancels. That cancels with that and that. And then I have minus 2e to the x and plus 2e to the x. So this does equal 0, so the answer is yes. The details of the calculation are just basic, derivatives, pretty much.
What happened to that last e to the x?
Just all canceled, my friend.
Okay.
Okay, yeah, just look at it. So you got minus this plus 2 times that, and then minus that. That all cancels. And then this e to the x has a 2 in front of it. Cancels with that. Right. What I could see myself asking you would be something like this. I give you, say, 2 of these solutions. Here's one. And then I give you another one. So I hand them to you. We get so wrapped up in solving these things, right? We learn the annihilator method, we learn variation of parameters, and we get really good at that, and we feel totally on top of it, and then we forget what in the world this is all for. What it's all for is to try to come up with the general solution to a differential equation, which means we just need to know the dimension, and we need to find a basis of solutions that has that dimension. So what is the dimension of the solution space of this operator going to be? 2. We learned that, right? We have an operator that's n order, then it will be n-dimensional in its kernel. So I need 2 vectors that are in the kernel. Here's one. So if I gave you even one more, then I would have given you enough, assuming that I gave you 2 things that were Li, which we can test. How would we test them? Once again, very good. Okay, so I could give you 2 things. I could say, check that they're both in the kernel. That's like part A. Part A is check that this is in the kernel, check that that's in the kernel. Part B is check that they're linearly independent, right? Part C then would be find the general solution and explain your answer or whatever. So the general solution would just be, well, since those 2 solutions were Li in a 2-dimensional space, they would form a basis, and therefore they would span every solution. And so every solution, which means the general solution, could be expressed as a linear combination of those two. Does that make sense?
How do you write that down?
Exactly like I just said.
In words, is what that is?
Yeah, just in words would be fine. I mean, you could say, so the question would just be, well, if I just say write down the general solution, all you do is you just say, well, y of x is equal to c1 times y1 of x plus c2 times y2 of x. y1 of x would be this one, right? That's your first solution. And then, so that's x e to the x, and then whatever, I'm doing this on the fly, I don't know what the second solution would be, but there'd be some other solution that's li, and you'd plug that in here, and then, I mean, I may not even ask you to explain it, maybe I just say write down the general solution, but if I want an explanation, then it would be along the lines of what I just said out loud, which is, this is a two-dimensional kernel, and I have two linearly independent functions. I use the Wronskian to check that, and so therefore the general solution has to be